Hi, this is Neil. I'm going to show you how I install a dead rail system into a locomotive. Today I'm going to focus on the battery component. The system I'm using is from Neil Stanton of Australia, and it's batteries that use the rails to recharge on board. So you don't have to remove them like this Shay here. And to control it, today I'm using a Tam Valley throttle, but there's a CVP T5000 or 6000 that would work fine, or the S-cab throttle is also good for controlling dead rail locomotives of different frequencies. The S-cab is pretty much frequency 916.48, and the Tam Valley one is very specific to this locomotive, in fact, is a 916.12, I believe, or 918.12. And then the CVP throttle, the T5000 or T6000, has different choices for frequencies. So you have a broad range, but frankly, there aren't that many choices for receivers nowadays. So you're going to find that you're going to be choosing a throttle based on the kind of receiver you use. So in this case, this is wireless directly to the battery on board. And I have a receiver in the cab of the Shay, and actually my Soundtracks decoder is underneath the locomotive. And inside, and I'll show you in a minute, is a large battery pack. I do build different size battery packs. They all have circuit protection so you can't overcharge them or discharge them too far that they become dangerous. I make my own plugs from headers. I didn't bring one out to show you, but maybe I can do that later. And then if you want to use a traditional system like your NCE power cab or your NCE power station, you can hook up an antenna directly to the bus, and that will transmit, for this loco, for example, through the wireless using your power cab or your throttle. And I believe you can do this with DCC, any DCC system, Digitrax NCE, and it will transmit all the DCC commands directly to the wireless receiver in there. So let me just show you how this works, and then we'll get into doing a battery install. And frankly, a lot of soldering can seem tedious because I like to make connections that could be removable. And I'll get into that, and we'll just simply show you how I did that. The one thing I'm not going to show you is the receiver, and we can do that another day. So please give me some feedback, and I look forward to your questions and answers. Thank you. Here is the subject, my 10-wheeler in ON30, and I have batteries and the Stanton battery management module. It's actually two boards back to back. It has 4 wires coming out of it. 2 come from the rails, so they are used to charge the batteries. And the other 2 are going to go to our receiver, which in turn will go to the decoder. So this is actually a 2-sided board, and you can see, it has 5 wires. One of them can be used as a control wire. If you have a Tsunami version 2, you can use it and turn it on and off using a function key. So there I'm spreading them out so you can see all 5 wires. The batteries will plug directly into the board, and they come with their own socket, and they can only be plugged in one way, and that's important because they are straight DC plus and minus. So you'll see it has a small white receiver and for the battery cable.
Right there's the battery cable, and you can plug that directly into the boards, just like that. There we are. Yep, like I said, they can only be plugged in one way. So I'm going to unplug it so we can keep these separate during the install. So let's focus on the locomotive. First thing we need to do in this case is get to the tender where all the electronics are located. So I'm going to take the locomotive and gently put it on its side. I can get a Kleenex or something to lay it on. I don't have a good cradle for this kind of thing, or a piece of foam. So we'll do this. And from another point of view here, you can see the tender and my locomotive. And I'm going to make a point of showing you, I mean, you probably have a different kind of locomotive, but this one has battery connections from the tender to the locomotive. And I'm just going to gently pry them out of their socket so we can take a look at the tender. So I'm going to start by removing the trucks, and the trucks take power from the rails. So if you remove the trucks, you can notice that they have insulated wheels on one side, and these took a little bit of effort to snap off. They only go on one way, by the way, and there you can see the pads where the brushes on the underside of the top side of the trucks make electrical contact. So we'll do that with both sides. Now that we have the trucks off, I need to take the tender shell off, and it has a couple of plastic bits that hold it in place. The two screws in the front are removed, and then gently these are popped out of the back of the shell, and it has a wire connecting the backup light. So I'm just going to remove that from the two leads so that this can be all separated. So that leaves us with everything exposed that we need to work on. So I'm taking a look to see where this battery module needs to go, because there's two locations where there's reed switches, and they're activated by a magnet, which I have on the end of this pencil. So one way or the other will turn it on, and the other way turns it off. But it doesn't have a very long range, so you have to keep it within about a ½ an inch of the magnet. So I was thinking if I put it on the side of the tender, that might work, but I thought maybe I could put the batteries on the oil bunker, but there's really not, that doesn't fit very well. So the idea of just leaving the coal load in is going to probably work best, because this battery module, the charging module, doesn't quite fit the way I expected it to in the tender, at least not without some modifications. So back to the coal load, I'm going to double-sided tape to the underside of the coal load so that when I use the magnet, I can run it across the coal load, left to right, right to left, and turn it on or off. So sort of that decided, I believe, that I could put the batteries in the tender shell and still have room for everything else that needs to happen there. So this has a NMRA 8-pin plug, and the wires that come from the rails are the red and the black. And it's hard to see in the video, but the red on this side, number 1 pin, and the black on the other are going to be the two wires we cut. So you don't need to be a Navy SEAL to figure this out, but you can see that the pin has a number 1 on it, and the board generally has a number 1, so you know that you can plug it back in the right direction. Honestly, if you don't get it in the right direction, what happens is the engine will run in reverse, and your lights will not be working the way you expect them to. Forward will be backward, backward will be forward. So if it happens to you, simply check that out and make sure they go back in the way they can. So this is a Tsunami board that came with the Bachmann 10-wheeler, and it's just held in place with a single screw. So you can see I'm looking again here. This is the black wire and the red wire. So the red wire goes to the decoder from the rails, and the black wire goes from the rails to the decoder. So what we want to do is intercept those. So ultimately I'm going to have the wireless receiver going to the, from the battery to the decoder. But first I need the wires to go from the rails to our batteries. So the battery module is sort of in between the rails and our receiver. Right now I'm just going to make a wiring harness that goes from the rails to the battery, and then we're going to make plugs that go to the decoder so that later on I can put the receiver in between the two. So this is going to become somewhat tedious to watch, so I've sped up the wire cutting and soldering. So I'm going to tin the ends. I'm cutting the wires. I'm going to strip the ends of these. I'll tin the wires after giving them a little twist, just so that they have a nice solid end that we can solder to. If you tin the wires on both sides, it makes it very easy for these to be soldered back together. And don't do like me and forget to put the heat shrink tubing on there until afterwards, but that's what I did. So this is moving along at twice normal speed here, a little bit of solder flux on each of these, and then I'm going to use my little teeny soldering iron. I believe you only need about 15 watts. It has a little fine tip end. The trick to soldering is to keep the tip clean and just to touch those wires. It shouldn't take more than about 3 seconds each just to get a good solder joint, right? That's all you need. So I'm going to skip through all the rest of these wires because it's the same thing. Put a little flux on these, clean the tip, and touch these wires together after tinning them so that they're bonded together. So I use these connectors I got. I buy most of these kind of things on eBay. They take a little while to get here, but then I have a good stock on hand. There's a male and female type, and they come in packages where you can get a whole bunch of these, and they're very inexpensive. I was using a different type, and I didn't have enough connectors, so this is the one I'm going to use. It's real similar to the battery cables, and I wish I could remember the name of these, but I'll look these up so I can share these in the notes. So again, I'll cut them to length. I'm going to strip the ends. I'm going to tin the ends, right, so that these can be soldered together. So let's skip ahead to the next step. So now that I have all the ends tinned and soldered together, I'm going to use some heat shrink tubing. You can use electrical tape, of course, but this heat shrink tubing comes in different colors and sizes, and you just cut off a little bit and you can slip it over the end of the wires that you've soldered together, right? And you apply a little bit of heat, and generally the edge of your soldering iron is adequate. It just takes a couple seconds for the heat shrink tubing to do just that. It shrinks around your wires and provides a nice protected wire so the bare wires aren't exposed. So I went through and did this on all 4 wires. I included this step and I put it kind of in slow motion just to show you that I've put a heat shrink tubing over both of the wires and the connection, just so I can keep them all together and keep my wiring rather exposed. It only takes a minute to get this heat shrink tubing to get a nice close and tight fit over both of the wires. So I'm just taking the edge of the soldering iron, not the tip, just rubbing it back and forth over that tubing. And again, it comes in different colors if you want to keep your red and black separated. I generally just use black because the wires are tied red to red, black to black. So that's pretty much it for what we're going to do today. We've got all the wires soldered together, heat shrink tubing around there, and the end connectors connected from the batteries to the board.
Make sure I got everything lined up right. From the rails through the trucks to the battery management side, out to the decoder. The battery would fit right in here. honestly don't know if they're charged, but the light didn't go on, so it doesn't look like they are. Now what this does is it allows you to charge the batteries from the rails, but obviously they'll go a long time without them, like a keep alive.